Good morning, students. As this welcomes you all. Now we are ready with a new topic. That one is factors affecting the resistance. In the last lecture, we have discussed about the resistance and the resistance series and parallel. Now we are going to study how many factors they are affecting the resistance. We should know factors affecting resistance. Let me tell you one thing. If we are taking a conductor of a small L length, then let us take a conductor of small L length and A cross section area. Let I be the current passing through it. If capital R be the resistance develops over it, then R is always directly proportional to L. That means resistance of a conductor is always directly proportional to the length. And it is also inversely proportional to the cross section area of this. It is always inversely proportional to the cross section area of this. These are the two key points that can affect the resistance. That means larger the length, larger would the resistance. And the cross section area, if larger the cross section area, resistance would be lesser. So like that, R is directly proportional to L and R is inversely proportional to A. We are just combining equation 1 and 2 by combining equation 1 and 2. We get what we getting here, that is R is directly proportional to L by A. Here, with the removal of this directly proportional sign, we know that one of the constants should come, and here the constant rho comes. That is rho L by A. This rho is called resistivity. And this is also called specific resistance. This rho is called resistivity and this one is also called specific resistance. If we are to give that definition of the rho, then rho can be written like R A upon L. R A upon L. If A is equal to 1 unit and L is equal to 1 unit. I am writing here unit just because if we are taking centimeter square, meter square, whatever we are taking, that is why I am writing here 1 unit and all that. Then rho becomes R. That means resistivity is the resistance. Resistivity is numerically equal to the resistance of unit length of a conductor of unit cross section area. I am repeating it again. Resistivity is what? Resistivity is the resistance of unit length of unit cross section area of a conductor. So this is all about resistivity. Resistivity can be written like rho is equal to R. So resistivity is also called what? Specific resistance. Remember this name. Specific resistance. Moving further, we are just going to discuss about two of the important topics. That one is conductance and conductivity. Let us discuss about these points. What is conductance and what is conductivity? As we have discussed about the resistivity, we have to discuss the conductivity and the conductance. Conductance. Whenever we are talking about the conductance is just the reciprocal or inverse of the resistance. Inverse of the resistance. Resistance what? Resistance is how much power, by how much power we can stop or we can put the obstacle in the path of the flow of the current. And conductance what? The ability of that particular conductor, how much current they can flow. That means they are inverse to one another. So conductance what? Conductance is written like what? It is the inverse of, it is the inverse of resistance. It is the inverse of resistance. Remember this always. And its unit can be written like 1 upon ohm, that is ohm inverse. Its unit is written like 1 upon ohm, that is ohm inverse, or it is also written like Simon. It is also written like Simon. I am writing it here. Simon. And moving further, the next one is conductivity. As it is the inverse of the resistance, as the conductance is the inverse of the resistance, then conductivity, which is written like sigma, is the inverse of resistivity. It is the inverse of resistivity. So what is that? It is reciprocal or inverse, whatever you can write, you can write down. It is inverse of resistivity. It is the inverse of resistivity. So this one is all about conductance and conductivity. I hope you are getting all these points. Later we will discuss in our next lecture. As this, will see you again in next lecture. Thank you.